Hello everyone. Welcome to this live session. I hope you're all well. This is the first GCSE session for maths. Let me have. Yep, we are just getting started. I was just sorting my my iPad. I had a little connection issue, but we are all good to go now. Yep, physics GCSE. I'll do that as well. We are planning on doing that as well. I hope you find the math sessions useful. So today we'll be looking at simultaneous equations. The way these sessions work is I give you an introduction to the topic. Sometimes we start with examples and then we'll after some explanation we'll move on to solving some more exam questions. Hi, let's get started with let me show you my screen. Hope you can see my notepad now. Hello everyone. Okay, it's great to see you all there. You have many of them joining us today. It's great. Is this? I'm just checking the questions. Is this higher? Nicole is asking. Well, this is as we have got both higher and foundation. So if we look at what we'll learn today, I will be starting with solving two linear equations simultaneously. That's in foundation. So everyone needs to know solving two equations simultaneously. Then we are going to look at solving a linear and quadratic equation that is only in higher. So this is let me make a note here, higher tier. So the first examples we are going to look at is just for foundation. How long will this be? Well, it will be under now it's about 45 minutes to an hour. Equation rate will be equal to 0. Let's have a look. I have some example questions I've already picked, and we can see if you want any other examples as well. You can let me know. So let's get started. As I said, we are looking at simultaneous equations, but I want to start with a recap of solving linear equations. So what is an equation? What do we try to do when we are solving equations? Suppose you are given this 2x plus 3 is equal to 7. Well, this is just the basic equation. It's a quick recap. Let me know what we are trying to do when we are solving this equation. What does solving the equation mean? So the idea here is we have got only one unknown. X is unknown, and we are looking to find what the value of x is, so that the left hand side of the equation there is equal to the right hand side. On the right hand side we just have 7. On the left it's the expression with the x, but in more complicated ones you can have x in all different places. The idea is, as you said, well done Fares and Sales. I'm not sure if I'm pronouncing your name correctly actually, but yeah, the idea is finding x. And to do this, what we do, let's see how we solve just a regular equation. You would say the idea is leaving x on its own. So the first thing to do would be taking 3 away from both sides. That will give you 2x is equal to 7 minus 3, which is 4. And then to get to x, you can divide both sides by 2, which will give you x equals 2. Well done, everyone who got x equals 2. So this is what you how you solve just an equation with one unknown. The only unknown here was an x. But what we are interested in today is what happens, seeing what happens when you have two unknowns. Instead of just an x, let's see what happens when you have two of them. So you have two unknowns, which is an x and a y. Usually those are going to be the variables, but it could be anything else. It doesn't matter. The idea is you have got two of them unknown. So for simultaneous equations, I want to look at this. I want to do this with an example. Actually, I find with this topic it's best to just work through examples. So what is the idea here? Instead of just one unknown, we have got two unknowns, but similar to before, we are still trying to find x and y. So solve means still find x and y. And you're looking for a value of x and a value of y, which will satisfy both equations. So before we were saying for one x value, you had the left-hand side equal to the right-hand side. But now we are going to look for two values, an x and a y, so that both of these equations are satisfied correctly. So that both equations are satisfied. So what can we do? Can someone suggest, do you know any methods what we can do? Okay, I can see Nicole, you can rearrange the second equation. That's very good. Fares saying sub x into the second equation. That's also very good. That's well done. The idea here is we can't find both of them at the same time. So what you need to do the first step is eliminate x or y. So that's the key. We need a way of eliminating x and y. So you can have, as some of you suggested, you can substitute one equation to the other, or you can add them together, add or subtract. So to eliminate, I'll write two that you have two options. You can either substitute or add or subtract. Okay, let's do this example. So let's go with the adding method. I will just rewrite these equations here so I have more space. 18, x minus 3y is equal to 7. So you have got some answers there. X equals 5. I think you are right. Well done. Let's see how we get there. So we said that we are going to add them together. Why are we adding them together? The idea is, remember, eliminating either x or y. So when you add these equations together, by adding, I mean you're going to add each term to the other corresponding term. So I'm going to add 4x to x. That's going to give you 5x. And then what's the reason this works is 3y plus minus 3y is 0. That's the cancelling. That's how you get rid of the y term. So they cancel out. So that's like plus 0. You don't really need to write it there, but I'm just putting it there so that you can see. Then on the other side, 18 plus 7, we have got 25. So this now became a regular or a linear equation with one unknown. We do what we did before. You can divide by 5, and x will be 5. Well done to everyone who got x equals 5. Then what's the next step then? We have got x equals 5. Have I solved this equation? Is this the solution to the simultaneous equation? Because I found x. Is that what I'm looking for? Well, we said at the beginning we have got two unknowns. So x is one of the unknowns, which means you still need to find y. So here found x. Now you need to find y. Right. Now, thank you, Natalie. We need to substitute this into the original equation. Yep. So we don't stop here. Don't forget, you want both x and y values. So to find y, you can go to equation, one of these equations. It's good to sometimes number these. So if you call this number 1 and number 2, you can refer back to them. Yep, let me know if you have a question, Jackie. I'll get to that once I find y. So we can substitute into 2. It doesn't matter which one. It doesn't matter which one you go back to, as long as you can rearrange and find y. It's okay. I'm just putting it into 2. You might prefer it because it's just 1x instead of more x's. So what you say is 5, that's place of x, minus 3y is equal to 7. And then you will continue doing it the other way. Jackie, you asked why did we add? You're right. Thank you, Jathur-san. If you have different signs, you add them so they cancel each other and it disappears. If you have the same signs, then you want them to take away. Oh, sorry, my com is blocking the writing. Let me make that. Let me change that. Sorry, I wasn't seeing that. I'll make this tiny. Right. Let me know if you have if there are any other issues with the tag. Yes, we are going to do quadratic simultaneous. So we have a few examples with linears. I want to explain these well, and then the next one we can do a bit faster, and then at the end we'll do quadratics. Right, this one, let's rearrange. So we can add 3y to both sides. 3y, 3y. So I'm writing these separately. I mean, depending on how comfortable you are, you don't really need to write these steps, but this gives you 5 is equal to 7 plus 3y, and then you can take away 7 from both sides. So you have minus 2 is 3y. Can the answer be negative? Yes, it can be. Don't worry if you get a negative or a fraction. So at the moment we have got 3y is minus 2. We divide by 3 on both sides. So the idea is making the 3y into y. So minus 2 over 3 is equal to y. So that's my final answer. We have found both x and y. That's what we mean by solving simultaneous equations. And if you want to try, look back to the first two equations that we have. If you could take your calculator or just do it manually, but the idea is if you take this y value and put it into there, then you take this x value 5, put it into there. Both equations should work. The left hand side, in the first one it should give you 18, in the next one it should give you 7. So that's the idea of simultaneous equations. Okay, let me know if you have any questions in the chat. Let me know how you are finding this. Is it easy? Is it difficult? Then I will move on to another example. This is still two linear ones. Try this one on your own. I will solve it as well, and let me know any questions. Shall we eliminate? Can we add them, subtract them? Which method would be the best here? So I'm rewriting them. I am missing a not minus sign, an equal sign. I mixed them actually. Let me fix this. So plus 2x plus 5y is equal to minus 10. It's easy, Nicole. That's great. You put it in the first equation or the second. It does not matter. The first, and this is referring to the previous question. It doesn't matter. You could have put it in the first one or the second one. It doesn't matter. It should give you, it will give you the same thing. I'm just numbering these again so that I can refer to them later. Subtract them. Holly saying subtract. Well done. We should subtract them. Natalie, well done. Because the signs are the same, we take them away. So remember this, you do this for each term separately. So that disappears. We have got 5y minus y. So that's going to be a 6y minus 10 minus 8 is minus 18. Divide both of them by 6. Y will be minus 3. Let me know if you agree with this and what the next step is. Do we get what should you get for what you should do to find x, because we are not done yet. This is just y, but remember, when you have a simultaneous, you need to find both of them. So you substitute into one or the two. It does not matter. Remember, let's do one this time. So when you're substituting into y, what you're doing is taking this 3 and putting it into there. That's what substitution means. So we have got 2x plus 5, and then minus 3 is wherever you see y, you put minus 3, equals minus 10. Multiply it out so that it's simpler. 2x plus 5 times minus 3. 5 times minus 3 is minus 15. This is equal to minus 10. And you want to leave x on its own. You will need to add 15 to both sides. So 2x is, so what's minus 10 plus 15? You should get 5. and then x equals 5 over 2. Let me know if you agree with this or whether you have a different answer. You have got minus 15. Check your answer. How you got minus 15? Yep, 2x is 5. So at the end you should have x equals 5 over 2. Well done, Nicole. You got the answer. And that's, again, you have both an x and a y value. Can you leave it as a decimal? Yes, of course. It's either 5 over 2, or you could also write it as 2.5. You have a different answer, 10 over 4. 10 over 4 is also the same because it's the equivalent fraction. I'm not sure how you got there, but you probably had higher, maybe you had 4x, I'm not sure, but 4 over 4 is the same. 10 over 4 is the same because you can multiply both the numerator and the denominator by 2 there. Okay, let's do another one. This is the last example for linear ones. So this time we have a problem. So you'll see that it's gonna turn into simultaneous equations. But we start with a problem. You're given a situation where you'll need to, instead of finding x and y, you'll need to work out the price of a coffee and a cake. So these problems require you to set the equations yourself. So that's a bit more that can be a bit more challenging. Can we do an exam style question? Well, the coffee one is a bit different. That's but the others were also from exam paper. So you do get questions in the exam paper which literally say solve the two equations simultaneously. But this one you have got a problem solving one. So tell me what we can do here. How do we turn this into some equations? This is an important skill in maths. You need to be able to turn situations like given in the question into equations so you can solve. So we have got coffees and cakes. You want to find the price. You're interested in the price, and then you have got two things. You have a coffee and a cake. So let's call these something. We can call it doesn't matter what you give them. Usually we work with x and y, so we can call them x. We can call coffee x, cakes y. Yep, that's great. Thank you, Holly. And the idea is we'll get simultaneous equations. But if you don't know that you'll get simultaneous equations, don't worry. You approach the question, you give them some labels, and then they will come out. So we'll see how that works. Right, coffee is an x. Let's call this an x. And then let's call this a y. Let me change my color so it's more visible. So this is an x, and this is gonna be a y. Tell me the equations that come out of this. So in this is one shop. We don't have different shops, but we are told that two coffees. So since we said that one coffee is an x, two coffees is 2x. So I'm literally turning words and sentences into mathematical equations. We are told that two coffees, let me put this there. So that's 2x and is a plus. Let me, 3 cakes is 3y. That's 9 95. So the translation here is 2 x's, 2 coffees, this is 3 cakes, this is costs. So I'm changing the sentence into an equation. So that's my first equation. The second one, that's going to come from the second sentence. So that's 1 and that's 2. Give me the second one. Holly says x plus 4y is 10.35. Well done. So we have got x plus 4y equals 10 plus 35. Great. If you got here, you have done the tricky part of the question. Because if you're happy solving simultaneous equations, you will be able to do it just as a simultaneous equation question now. It doesn't matter it's talking about coffees and cakes and it's in a shop. It doesn't matter. So let's solve this. So this is coming from the second one. Should we add, subtract? What are we gonna do? Can someone give a suggestion? Okay, can we add them or subtract them? Is it gonna work? So Merlin is saying times the second one by 2. Well done. We need to do something different here compared to the previous ones, because you can see that you don't have the same x values or the y values. So let's make a note of that. We don't have the same x or y values or coefficients. So what's in front of x or y is not the same in two equations, so you can't just add or subtract. So what you need to do is times the second equation by 2. So how do I know it's by 2? Well, because we have got a 2x there, whereas this is just an x. It's a single x. I want to make them the same. So that x terms are the same. Okay, so the first one I'm not gonna change. That's 1, 2x plus 3y equals 995. What do I get when I multiply the second one? Has anyone done that? Let me know. Because I am getting the second one times 2. Let me move it a bit that way. We have got 2x plus 8y equals 20.75. Yep, let's see what these will be. So I got this one because I times everything here by 2. So 2 times x is 2x, 2 times 4y is 8y, and that's how I got the other values. Thank you, Natalie. Thank you, Holly. That's your other equation. So now what do? Do we add or subtract? Yep, it's 70. It's not 75, it's 70. Thank you. That was a mistake. That's better now. What do? Do I add or subtract? We have got the same values, same 2x, so you need to take one away from the other. So you have got minus 5y is equal to minus 10.75. So you may have subtracted them the other way, which could be better actually. So if you don't like negatives, you can just rewrite them So you can do 2x plus 8y equals 20.70. So you can do it this way as well. It doesn't really matter if you don't like negative numbers. I mean, there's no reason you shouldn't like them actually. But you may prefer it the other way. You may be used to that. That's absolutely fine. But in this case, you would simply divide by -5. So you should get the same answer. So y at the end should come to 2.15. Is the live still going on? Yes, it is live. I'm here. We are still going on. If you have just joined us, we have done two linear equations. We are just about to move on to quadratics. So y is 2.15. This is, we said you could do this alternatively or this way. And then you need to sub into one of the equations. You might want to go back to 2 because that's the x is already on its own there. Okay, substitute into number 2. Let's find x there. So we have got x plus 4 times y, 2.15, is equal to 10.35. And expand the bracket, multiply it out. That should give you 8.60. And take that away from both sides. 8.60, 8.60. That should give you your x value. I have 1.75 for x. Let me see, did anyone else get x the same as me in the chart? Yeah, so we have got x and y. We have solved the simultaneous equations. But that means what was x? If you go back to the question, x has a meaning. So x is the price of the coffee. Y is the price of the cake. So you can write them down. Therefore, coffee price is 175. It's not a nice 5. And then cake price is 215. Right, well done. I think looks like you have x. Yes, am I going through quadratics? We are, that's what we are going on to now. So let's have a quick recap of quadratic equations. What is y? Yes, y was cakes, x was coffee, y was cake. And 2.15, that's, yes, that is correct. Jackie, 2.15 for y is correct. Okay, quadratic equation. So we have seen this is higher, by the way. I mean, quadratic, these simultaneous equations with quadratics that we're going to do in a sec. But let's recap quadratic equations, because what we are going to do now is solve a linear and a quadratic together. So what's a quadratic? Tell me what we have there, and I'm going to write an equation so that we can solve it together. So this is a quadratic equation. What makes it quadratic? Let me know in the chat. What do we do when we are solving this one? It's an equation, so the idea is still finding x. It's that you have one unknown. But how do we find x here? Let me know. Is x 1.75? Yes, previous question, x was 1.75. Holly says x squared. What do we do with the x squared? Is that how what did to solve this, or is it what quadratic is, Holly? Will IGCSEs get cancelled? Well, I don't really know the answer to that. There are, I mean, it really depends on the country you're in and the exam board. So I don't know where you are really, but I know that in the UK they're not going forward. Internationally, there are some like CIA will make some their exams in some countries. So it really depends. Okay, how do we solve this? Some suggestions in the chat are factorize. Well done. That's we will get there. Thank you, Holly. That's a quadratic. So let's get back to that. So a quadratic is when you have an x squared term. That's when you know you have a quadratic equation. It's a quadratic term, and if you're solving an equation, that's the that's you know how you need to solve the quadratic equation. So solving this, we need to the first step here is moving all the terms onto one side, and then you can use either factorization. So you either, let me write first step, move all terms to one side, then either you factorize, you complete the square, which this we are gonna do a session on completing the square. I think it's next week actually, or you use the formula. So you don't you can't really, unless it's a very simple one, you can't really take the square root unless x is on its own. You can't really do that. So you need to use one of these three methods. In this case, you'll see that this can be factorized. So let's do what I suggested. We are gonna take all the terms to one side. So I'm gonna move them to the right, or add x squared, take away 7x. So this is going to be x squared minus 7x plus 12. Yep. So this is the first step. We make one side equal to 0. Let me know if this can be factorized and what brackets you have. Quadratic equation or factorized? Yeah, can you give us questions to solve? What do you mean, Jackie? I'm not sure I get your question. Okay, we can factorize this one. The factorizing, assuming you have you have done factorizing before. So the idea here is when you expand the brackets, you will get the same. You'll get the same quadratic expression. So what you can do is you can look at the first term there. That's an x squared. So the brackets should be x, and then you can look at the last term there. That's at 12, and you should think which two terms multiplied give you 12. So that's going to be 4 and 3. So the 12 you need to, since you have 12 and minus 7, you need two terms, two numbers that multiply to give you 12. and they should add to -7. So that's why you can factorize with two brackets with -4 and +3. So when you factorize it this way, you should you can always check again whether it works. You can expand the bracket, you can go, this is an x squared, and then we have got 3x minus 4x. That's not right. Okay, this needs to be minus, of course. Yep, thank you for correcting that. So you can check it. As you can see, I expanded it, and I can you can realize easily if you have made a sign mistake. So you have got -3x minus 4x, that's -7. That's how you factorize. Right, so what does this mean? How are we gonna solve this equation? So remember, the idea is the left hand side is 0, so you have got two brackets multiplied to give you 0, and the idea is that either bracket can be 0. So either x equals 4 is 0 or x minus 3 is 0. This is because if one bracket is 0 there, it doesn't matter what the other one is. The overall the expression will give you a 0. That's why quadratic equations work this way. Oops. So x is equal to 4 or x equals 3. So that's the answer. That's solving a quadratic equation. So this is not a simultaneous one. This is just a quadratic on its own. But that's how we solve them. And when we have simultaneous, we'll still need to solve quadratics. Okay, just checking out your questions. If they gave you big numbers, well, it depends really. If they're big numbers, sometimes they can't be factorized. You can use the quadratic formula, but they won't give you, if you are on a non-calculator paper, then you're not going to get huge numbers. So if you do, then you can use the formula, the quadratic formula, but you wouldn't get huge numbers that you can't really do anything with. Okay, let's look at a simultaneous involving a quadratic. So this was just solving a quadratic. Right, this is what we have. It's the same approach. The first step is still eliminating either x or y. What can I do here? Which one can I eliminate? Can I get rid of x or y more easily? And what method can I use? Can I add like I did in the previous ones? So can I do this plus add one to the other and expect some things to cancel? The issue with that method is you can see one is an x term, one is an x squared term. So that's not going to cancel out. They're not going to cancel out. What you need to do here is use substitution. You need to substitute x or y into the quadratic. So remember, with quadratic ones, where you have a quadratic and a linear, you have to substitute. You can't use elimination. That's the important information here you should remember. You have to substitute. And I'm looking, this is nicely an x on its own, so I'm going to substitute it in there. So do the substitution, let me know what you get. Question, Ashraf, how do we know whether to decide to use the quadratic formula or factorizing and completing the square? Well, there isn't an answer, a definite answer to that. In many cases, it doesn't actually matter. whichever one you prefer is the answer. Factorization is a bit more restrictive. You can't factorize all the time. So if you have nice, easy numbers like the previous question, you should factorize. That's faster. But if you can't, you could use the formula or the completing the square. They're roughly the same thing, whichever one you're more comfortable with. Right, let's do this. I'm going to substitute x into the first one. So that means wherever I see an x, and in this question it's just appearing once, there is no coefficient, but it's always the same, I'm going to place y minus 5. So instead of x squared, that's my x squared, I'm going to say y minus 5 whole squared. The next term is y squared, and that's equal to 30. Right, Jackie, y squared plus 25. Let's expand and see. It looks right, actually. How do I expand this? So this is, again, make sure you're familiar with how to expand brackets like that. So I'm going to do that on the side. So we have got y minus 5 squared. This is the same as y minus 5, y minus 5. So you can do this in a longer way, which is multiplying everything, each term together. So you go y squared, that's the first two together, and then you will do 5 times y, minus 5 times y, minus 5 times y, and then you can finish by multiplying the two 5's. So that's expanding the brackets with every term separately. So let me write that out. Minus 5y plus 25, and y squared minus 10y plus 25. So that's what the first term is there. Then what you can do, though, if you have a bracket squared, you can see a pattern here. This is always going to be double the term, so you can always go the first term squared, y squared minus 10y, which is always double this, plus square of the last term, and that's plus y squared is equal to 13. You then simplify this, so add similar terms together. Thank you, Jackie. I hope we'll get there one day. Add them together, you will get 2y squared plus 10y. Take the 13 away from both sides, and that should give you plus 12 equals 0. So tell me, how can I solve this? You can see that I've reduced two unknowns into one unknown now. So only y, it's a quadratic in y, and we can use one of the three methods: factorize, formula, complete the square. What can I do here? Let me know. Can I factorize now? Can I do it a bit simpler? Can I do something to simplify things? So you can see, if you are at this stage, make sure you simplify your terms as much as possible. So you can see that there is 2, 10, and 12. There is a common factor. So you should, before factorizing into two brackets, you can factorize a 2 out, or you can divide every term by 2. So let me write it in the long way. So you're taking a 2 out plus 5y plus 6 equals 0. And then at this stage, you are dividing both sides by 2. So you end up with y squared plus 5y plus 6 equals to 0. Then this is factorizable. Let me know what your two brackets are. Right, questions, where did the 13 go? Yes, thank you, Ashraf. The 13 went to the left-hand side, or I should be really saying I took 13 away from both sides. So that means on the left you have got 25 minus 13. That gave me the 12. And yeah. So the brackets. What brackets have I got here? We have got y and another y. So I'm looking at the first term. That's a y squared. That's how I know it's I have two y's. And then the last term is a 6. So I need two numbers that multiply to give me a 6 and add up to give plus 5. That's going to be 2 and 3. Is that right? Did I miss something? There is a sign mistake here. Who can spot that? Okay, where are you confused? Which x are you referring to? Oh, yeah. Holly, yes, thank you. That's what I was looking for. The x, okay, sorry. This 10y is, you can see here, that should have been negative. Okay, let me fix this. So this is just, so everything is negative actually. The 10y's are negative, so this is negative, this is negative. Okay, sorry about that. Let me erase this. So instead of a plus 5y, we have got minus 5y. Where did the x go? We substituted, so that's at the beginning of the question. Here we eliminate either x and y. It doesn't matter which one. In this case, it's easier to eliminate, substitute x into the other equation to eliminate it. So that's why we are finding y now. Then at this stage, we factorize y minus 3, y minus 2 equals 0. And then, yeah, thank you for all of you who pointed out the 10. Y is 3 or y equals 2. Right, we have got two answers now. Y is 3 and y is 2. So what does that mean? Is that the final answer? What do we do at this stage? Remember, previously when we were solving linears, we had two answers, an x value and a y value. But now we have found two y values. Something to remember with quadratics is they will have two sets of answers. Two sets of x and y values as answer. But what's important is they come in pairs, so it is a set. It's not each x will have a corresponding y value. So remember, at this stage, what you need to do is say when y is 3, you substitute that into the original equation. Yep, don't forget the x. Always you need both x and y values. So what can we substitute back into? Is there a preferred equation? Just like the previous, let me make this everything visible. Just like the linear ones, it doesn't matter. It doesn't matter which equation you sub into, but in linear and quadratic ones, it's always easier to substitute into the linear one. So if this is equation number 1 and equation number 2, you should go to equation number 2. That's already an x on its own, so you can easily find the value of x. Then x is equal to, so that's y minus 5. Let me write this down nicely so I don't have to scroll a lot. So equation 2 is x equals y minus 5. So when y is 3, x equals 3 minus 5, which is equal to minus 2. And when y is 2, x is 3 minus, not 3, 2 minus 5, which is minus 3. Well done. It looks like we have the answers, 3 and 2. So the key here is remembering they come in pairs. So your answer is y equals 3 and x equals 2. That's one pair that will satisfy both of your equations. And the other pair is y equals 2, x equals minus 3. Right, that's the end of that question, and that's where we will stop today. Thanks for joining this session. If you found this useful, please subscribe and hit the like button. We are going to continue these sessions weekly. Next one, the next session is going to be on, let me have a look, it's going to be on completing the square. So it's related to what we did this week. It's it's related to quadratics, and it's a higher tier topic. Next week it will be the same time. Just checking if you have any questions. If we do it anyway, yes, that's a good question. That's a very good question, Jackie. If you can do it in slightly different ways, you don't, like, you could substitute a different one, you could eliminate y at the first, but you must get the same answer. That's how these equations work, because there will be only specific solutions. Any other questions? Just checking. You're welcome. Like Natalie, Jackie, that's great to hear that you're finding our resources useful. And bye for now. I hope to see you next week.